6.6. Sketch and use the graphs of sinx, cosx and tanx. This is part of my ultimate revision guide for further maths GCSE. This is the geometry section. We have an index button here that will take you back to the index for geometry, and then there's an index button there that will take you back to the index for all the indexes. And then down here, any exam questions that I've been through, I will link into here so that you can click on those to practice this topic. What I'm going to do is I'm going to go through how to draw these curves and what's useful about them, what you should know about them. You need to be aware that there's things called asymptotes and tan graphs. That's these dotted lines, and I'll talk about those in a minute. But you don't actually need to know the word asymptote because it won't be used in a question. There's a couple of questions here you can practice on. I'm going to go through those after I've talked about the graphs. Okay, let's go on to sine, cos and tan graphs. Okay, so here's three sets of axes. Let's have a look at the sine x graph. So y equals sine x. Okay, to draw a sine x graph, first of all you've got to be familiar with the shape of the graph. So the sine x graph is a sort of up and down curvy thing. Things we need to be aware of are the maximum value and the minimum value and where they occur and where it crosses at the x-axis. So once you know these 1, 2, 3, 4, 5 points, you should be able to just draw a curve through the points. So the first thing we need to know is that the maximum value for the sine x graph is 1, so it goes up to 1, and that happens at 90 degrees, and it comes back down through 0 at 180 degrees, and it goes down to -1 at 270 degrees, and then back up to 0 at 360. And then you've got to try and draw a curve through these points, and this is going to be quite tricky for me on this using this tablet I've got here, but we'll try. That's not too bad. Thing is, you got to remember is this quite flat at the top here, so you got to do a flattish curve there, and then nice and steep here. A bit of practice, and you'll get that sort of curvy shape. It's almost like a semicircle there, but not quite. Depends on the scale. Okay, so that's the sine graph. We'll come back to this in topic 6.8 as well, but we need to know not only this value, but we need to know the values at 30 degrees, 60 degrees, and even 45 degrees, as well as 0 and 90. So we for this course, you need to be aware of those 5 values for the sine x, for the cos x, and for the tan. Now cos is very much like sine, except for it starts here and ends 90 degrees later. So we're just pinching this part of the graph from the sine graph and putting it, making it the cos graph. So it starts at 1, it goes down through 90, down to -1 at 180, up to 0 at 270, and back up to 1 at 360. And these are repetitive graphs, they keep on going forever, but we tend to just at this sort of level stick to between 0 and 360. So this is going to curve down, curve back up here, and back up to there. Okay, so that's the cos, y equals cos x graph. And then we've got the tan graph. Now the tan graph has these things called asymptotes. The first one is at 90 degrees. The reason why it has an asymptote here is because the tan graph is made up of the sine and cos graph. Tan of any degree, any angle, is just the sine value divided by the cos value. So when you get to 90 degrees, you're doing 1 divided by 0, which is undefined. So as it gets close to 0, this value goes off and off, gets bigger and bigger and bigger. And then underneath, when you divide it by a minus small value, it comes on from the bottom here, and then it goes through 180, and you have what's called a point of inflection, where it just turns around and comes back the other way, goes back up again, off to infinity at 270, and then comes back on the bottom, and back to 360, and then it does it all over again. So there's quite a bit of sort of repetition going on here. We've got symmetry. Anything on this side, this top part of the graph, let's actually colour that in a different colour. So this top section of the graph is symmetrical about 90 degrees. So anything on this side is the same value on this side at the same distance. So if this was 30 and 60, this value here at 60 is the same as the value here at 30 plus 90, which is 120. So if I go 30 degrees to 90 and then 30 degrees the other side, those two values are the same. Similarly, these two values are the same for 30, and then this one here, which would be 150. If I'd drawn it properly, they would be the same values, and so on. So there's that symmetry there, and then these values are exactly the same as these values, but with negative values. So this value here at 210 is the same as this value here, but just minus, because it's the same part of the curve. It's just going down into the negative section. So this would be at minus, should be minus a half. This one should be at half. It's actually an exact value. And the cos graph is exactly the same, because it's the same graph, it's just been moved sideways. So the same ideas apply. So this value here is the same as this value over here, and this is at 60, so this is at 300, because they're 30 degrees either side of that zero value. And similarly, this value here is the same as this value down here, if drawn correctly. So that's 30 degrees from 90, so that's 220, except for that's negative value and that's positive value. Although on my graph it doesn't look like that, but that should be a half, and that should be minus a half for that value. If I'd drawn it properly, it should have gone through there at minus a half. The tan graph has similar sort of properties, symmetry. So these values here for 60 degrees is going to be the same but negative for 120 degrees. These values repeat every 180 degrees, so this value for 60 would be the same as this value for 240. So lots of things that you need to be aware of for these curves. Let's have a look at some questions. Okay, so sketch the graph of y equals cos x, state the coordinates of the points of intersection with the axes, write down the minimum value of y. So that's just some standard sketching of the graph I've just drawn. So let's go through that again. Here's our axes. The cos x graph starts at 1, so if we put 1 onto here, we've got to do the points of intersection with the axes. So we start at 1, we go down through 0 at 90, down, so it's almost like a diagonal coming down here to 180, and then back up through 270 and 360. This value down here is negative 1, and then we just got to draw in the curve best we can between there. Making sure we try to go through our points that we plotted. The minimum value of y, so what's the minimum value? Well, that's going to be minus 1. Okay, so that's pretty standard. So once you get used to drawing these curves, this sort of question is going to be fairly straightforward. The second question we've got about the tan graph. The sketch of the tan graph is shown. How many solutions of tan x equals 2 are between 0 and 180? So between 0 and 180, tan x equals 2 would be some value here. There are 2 in between 0 and 160, but this one is above 180. Sorry, 0 and 360, so this one's above 180. So there's actually only 1 between 0 and 180. In fact, there's only ever one value of anything between 0 and 180, apart from maybe the 0. So there's just one solution. How many solutions of tan x equals minus 0.4 are between 0 and 270? So minus 0.4, so some value down here, minus 0.4. It doesn't matter where it is on this graph. If you just draw a line in, you can see again there is only one value here. This value here is above 270, so just one solution. So we're not actually trying to find anything here, we're just told to say how many solutions there are. And then we've got C, write down the solutions of tan x equals 0 for 0 to 360. So where does it equal 0? We're including 0 and 360, so we've got this one here, this one here, and this one here. So this is all about reading off a graph. As long as you know what the graph is, if this one's drawn for you. So where does tan x equal 0? Well, that's when x equals 0, 180, and 360. So these sort of questions about reading off the graph.